Our objective in today's lesson is solving quadratic equations using the quadratic formula. The quadratic formula is a formula that will solve any quadratic as long as it is in standard form. So we're going to make sure that we can put a quadratic equation into standard form and then apply the formula to find the solutions. So a quick reminder that standard form means that the x squared term comes first, the x term comes second, and then we have our constant last, and it is always set equal to 0. We call this first coefficient of x squared a, the coefficient of x we call b, and our constant we call c. So whatever number is before x squared is a, coefficient of x is b, and our constant is c. We take those a, b, and c and plug them into our formula, and then finally we will simplify the expression to find our two solutions. The quadratic formula will be given to you on a formula sheet. However, you will be using it often enough that you should try to memorize it, and there's a song that can help you do so. The song goes, x equals negative b plus or minus square root b squared minus 4ac all over 2a. Now that we know the steps in the formula, we can put this into practice. So step 1 is to put this in standard form. So I am going to move the 4 onto the left by subtracting 4 from both sides, and I will get x squared minus 2x minus 4 equals 0. My second step is to identify a, b, and c. So a is the coefficient of x squared, that's a 1. B is the coefficient of x, that's a negative 2 because standard form says plus bx. And c is negative 4. So the next thing I need to do is plug a, b, and c into my formula. And just to make sure you're memorizing it, we're going to sing it every time. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So here I'm plugging in a negative 2 for b, so that gives me x equals positive 2 plus or minus the square root b squared, so that's negative 2 squared. Don't forget the parentheses so that we remember we're squaring a negative number. 4 times 1 times negative 4. And that is all over 2 times 1. And my last step is to simplify this expression. And you'll notice that when we simplify, we're finding two answers. One when we add and one when we subtract. So my first one, the positive, or excuse me, when I'm adding, it may or may not be a positive value at the end, is going to be x equals 2 plus the square root. Negative 2 squared is 4. 4 times 1 times negative 4 is negative 16. And then 2 times 1 is 2. So as I continue to simplify, I have x equals 2 plus the square root is a grouping symbol, so that is the square root of 20 over 2, and that's my final answer. If you learned how to simplify square roots earlier in the year, or if you have a calculator that simplifies square roots, you can rewrite that as the square root 2 times the square root of 5, all divided by 2, which would give you a final answer of x equals 1 plus the square root of 5. Alternatively, right here at this step, you can plug this into your calculator. If I do 2 plus the square root of 20 in my calculator and then divide that by 2, I will get an answer of approximately 2.71. Now I'm going to apply the minus. So when I subtract, I will have x equals 2 minus the square root of 4 minus negative 16 all over 2. That gives me 2 minus the square root of 20 over 2, or 2 minus 2 root 5 over 2. So x is 1 minus the square root of 5. Again, alternatively, you could put this in your calculator and you would get 2 minus the square root of 20 over 2, which is approximately negative 1.2. So those are our two solutions to this equation, 1 plus the square root of 5 and 1 minus the square root of 5, and the approximate values are positive 2.71 and negative 1.24. You can plug those values back in to double check that they work. However, keep in mind if you're using the approximations that since you rounded, you will get an answer that is slightly off. So let's try another couple of examples. In this next example, I am not given in standard form again, so I need to move the 3 onto the left to do step 1 of putting my equation in standard form. 2x squared plus 5x minus 3 equals 0. Second, I will identify a, b, and c. A is 2, b is 5, and c is negative 3. Step 3, I'm going to plug a, b, and c into the quadratic formula. Again, which is x equals negative b plus or minus square root b squared minus 4ac all over 2a. So my equation is x equals negative 5 plus or minus the square root of 5 squared minus 4 times 2 times negative 3 all over 2 times 2. When I simplify, remember I'm doing one expression where I add and a different expression where I subtract. So the adding expression is going to give me x equals negative 5 plus or minus the square root of 5 squared is 25, minus 4 times 2 is 8 times 3 is 24, so minus negative 24, all over 4. Simplifying, I get negative 5 plus or minus the square root. 25 plus 24 is 49, all over 4. This problem is a little bit different because 49, the square root of 49 is just 7. So I have negative 5 plus 7 over 4. And I just realized that I had kept that minus sign in here for a little while, so I'll get rid of that. And now on my last step, I have negative 5 plus 7 is 2 out of 4, which is 1/2. So my solution is x equals 1/2. Then I have my other solution with the subtraction sign. I have a negative 5 minus the square root of 49 over 4, which gives me negative 5 minus 7 over 4, which is negative 12 over 4, which is negative 3. So my two solutions are 1/2 and negative 3. And you may have noticed at the beginning of this problem that in fact, I could have factored to solve this. So I just wanted to show you that even when something is factorable, we could choose to use the quadratic formula. I'm just going to do a quick demonstration of how you could have solved by factoring. And you'll notice that we get the same solutions no matter which way we do the problem. We still get the two solutions of 1/2 and negative 3. Okay, one last example and then you guys will be ready to practice on your own. So in this last example, sometimes we get so comfortable moving things to the left side of the equation when that's not really always necessary. If I move these to the left side of the equation, I end up having negative a and b values. And I tend to feel more comfortable when my a values are positive. Of course, the formula will still work with a negative a value, but I like to keep my a value positive, especially when I'm doing factoring, so it's more of a habit. So I'm actually, instead of moving the 3x squared and the 5x to the left, I'm going to move the 20 to the right so that I have 0 equals 3x squared plus 5x minus 20. And now I am ready to assign a, b, and c. It doesn't matter if it's on the left or the right. What matters is that one side is 0 and one side is in standard form. Sorry to do the song without you this time. I just wanted to make sure that you had plenty of time to practice. So I found a, b, and c of 3, 5, and negative 20, and I plugged it into the formula. And now I am going to do my plus and minus and simplify that formula. After I simplify my a, b, and c, I end up with negative 5 plus the square root of 256 divided by 6. And then plugging that into the calculator, I get approximately 1.88. Similarly, when I do the subtraction, I'll end up with negative 5 minus the square root of 265 over 6. And when I plug this one into the calculator, I get approximately negative 3.55. So I now have two solutions, approximate solutions. These are my exact solutions up here, my approximate solutions down here, and you guys are ready to do some practice. So as a reminder, our objective today was to be able to solve equations, quadratic equations, using the quadratic formula, and making sure that we can get our equations into standard form so that we can identify a, b, and c and simplify our formula once we've plugged in our values. And I'll just leave you with our song for the formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a.